Hi, delighted to be presenting to you guys today. My name is Patricia Scanlon. I'm the founder and CEO of SoapBox Labs. So just to give you a quick background, I am an engineer. I've over 20 years experience in the area of speech recognition and AI technologies. I have a PhD in speech recognition. I'm also a parent, and based on the needs of my own children, I was inspired to found the company back in 8 years ago, back in 2013. So SoapBox Labs, we deal with child-specific voice technology, and one of our major use cases in education. So we take kids' voice seriously, right? We've spent 8 years developing child-specific voice technology. So we've had a laser focus during that time on children ages 2 to 12. So we've built a world-class team. We're 30 people here in Dublin now. We've over 130 years collectively of speech recognition expertise in the company. And we've commercial and academic partners throughout the world. So we're very specifically focused on accuracy and also on our privacy-first approach, which delivers off-the-shelf bespoke solutions for third parties. So we deliver the voice technologies for third parties to integrate into their products and services for children. So we voice-enabled products across multiple verticals and locations around the world. So why the need to do voice technology? Why did we bother focusing on this when there's so much great AI speech recognition technology out there? Well, back in 2013, while I was watching my child interact with technology and realizing that there was a very significant gap in what was available for children. So I realized at that point I'd spent my whole career in speech recognition actually working on adult speech recognition technology. And when I was watching my daughter interact with early reading apps, literacy apps that were trying to teach her phonological awareness and blending, decoding, and all these wonderful apps and fantastic production, fantastic pedagogy. What I realized was they all were missing an accurate system to be able to assess her ability to recall and pronounce sounds. And when I, as an engineer and a PhD in speech recognition, I'd spent my career in this subject, and I actually began to realize there is such a big difference. So people kind of take a glance going, yeah, sure, kids' voices are different. But when I looked closer at it, I realized they're not just slightly different. They're not just like a slight accent or something you deal with later. Dealing with children's voices using systems that have been modeled on adult voices, modeled on adult behaviors and adult language, actually will never work well for children. They'll work okay, they'll work to a certain point, but you will always hit a ceiling and where you will not get beyond accuracy, because those systems and children's voices and adult voices are so vastly different in so many ways. It confuses the speech recognition system and the AI systems. And in order to be able to deal with it, you need a bespoke system for children. So let's get a little bit specific on it. What is it about the difference in the voices? Right, so children have smaller, thinner vocal tracts, shorter vocal tracts, and smaller vocal folds. This changes the location of the information when a child speaks in the spectrum, in the spectral domain. So we have the time domain with the spectral domain. And that can really mess with a system when it's constantly. So what we do as humans, when we listen to adults or children, we tune in order to be able to comprehend both. But when you build a system built for adults and then you don't do anything extra, you don't do any changing, you just add a little bit extra data and hope the system can figure it out, you end up getting serious degradation in performance with children. It's not just in their voices, not just in the physical voices, it's in their language. So think, how does an adult speak, right? There's actually remarkably little variation between how adults speak once you take into account accents and dialects. But we all conform pretty well in that sense. Children, there is a huge variability in how they speak, not just in their voices, but in their language. They don't tend to conform to language rules. They tend to behaviorally whisper, shout, over-enunciate, over-pronunciate, take big gaps while they're thinking, so they over punctuate, which really messes with a system that's constantly looking for an end to the user's speech. And as you can imagine, so it's language and behaviors and physical voices. Now, what happens as children grow is it changes, right? It changes from the ages of 2 to 4 to 6, 8 to 10, and very quickly. Anyway, if you think about it, of course it does. They're maturing, they're developing, not just physically, but their brains and their language and their behaviors as well tend to start to conform as they get older. So that is a huge amount to contend with. And then you try and use a system that also works pretty well for, a 60-year-old male or a 50-year-old male or a 45-year-old woman. And you can begin to start to understand why this possibly might not work so well for kids and might never work very well for kids. The environments that children inhabit. One thing I realized back in the early days is that young kids are never alone. They rarely will go into a room and sit quietly and use technology. They tend to be around adults in the background, maybe TVs in the background, other children, dogs, classrooms, outdoors. They don't tend to be in isolated situations. And a lot of speech technology for kids that has been designed over the years and brought to market often tells you in the FAQ to use, if it's not working, maybe your environment's too noisy. In the real world, and a contemporary solution to speech recognition should not have that requirement. We don't have that requirement when you think about smart assistants for adults. We shouldn't have that for children. But the reality is technology for children to date has been lagging adult technology for by about 10 years. So we have all these constraints in order to make it work. And that's not right. That's not a contemporary solution. It's not the expectation of end users, consumers, and children themselves, right? They see adults and other people using speech technology and having a very successful experience. And it is extremely frustrating to not have that experience. Another thing to note is that children have very different privacy needs to adults. It's not just as simple as to say we get consent and then we treat the data exactly as we would an adult. We need to have differentiated privacy policies and we need to have transparency about the data. So privacy needs for children, on top of all these other needs, are paramount for accurate systems and systems that are usable in this space. So I just want to play a very short video of how children's voices change over time, just to re-emphasize that point that I just made there. So I'm just going to play this video.
Umbrella.
Umbrella.
Umbrella. Umbrella. Umbrella.
So you can hear in that very cute video how a child voices change over time. So it's not just, and just to note for all the techies, that they were normalized utterances over the whole utterance. So it's not that if the child was speaking louder than the older child or the adult, that difference is seen there. This is just normalized spectral. So this is, where does the information lie? The information tends to lie in a lot higher frequencies. So these are spectral things, so you can actually see where it is. So it starts from low to high when you go up on the y-axis, and this is across in time, right? So what you're seeing there is the fact that using systems that are looking in different parts of the spectrum for information when it comes to adults and even older kids, right? The 10-year-old there. You begin to see how as 10, 12 and the voice starts to mature, that it starts to look more like an adult. And you can understand then how a voice that is more mature and more adult-like will have better success. And then you start to see, okay, right, so when they're 7 and when they're 4, now we begin to understand why performance starts to dip. The younger the child, the worse the performance. And that's really, really important to understand. And it starts making sense then, right? You can see the performance and the experiences and the frustrations that we get. So what's really, really important in today's world is accuracy, right? What is the performance of the system? And that is really key. And it's particularly important, let's say, for this conference here when we're talking about education. When we founded the company, we decided to set the bar pretty high for ourselves initially. We wanted to be able to deliver voice technology in education, and we wanted to be able to deliver it for young children. And what we wanted to ensure that if you can hit those bars, you can actually do it for everyone and right up to the age 12. But to get it for the young voices was really, really difficult because of, as I showed you there, the young voices are vastly different to the adults. And that was important. And the expectation, like I said, is that we have high accuracy in the world today. So that expectation is there from parents and teachers and children themselves. So the children are experiencing what voice technology built for adults was about 10 years ago. There really are, most systems are lagging by 10 years. So not to say they won't work, they will, but they'll be quite a frustrating experience. And let's dive into that a little bit better. And this is particularly what SoapBox Labs addresses, is that what do we mean when we say high accuracy? We mean that, let's look at what a false negative is, right? So a false negative is when you are telling a child they're wrong when they're right. Now think about that for a second. Think about a 5-year-old or an 8-year-old. They've said something right, they've pronounced it, they've recalled it, they've read it, they've pronounced it. Let's have all the things that the kid does. They've answered their comprehension question correctly. They know they have, but the system tells them they're wrong. That is infuriating for any child. But, we can laugh and say it's infuriating, but it's actually quite damaging as well. What you're doing is telling the child they're wrong when they're right. That's not education. We have to be super careful that these systems that are brought in front of children are not doing that and damaging confidence. On the flip side of that, telling a kid they are right when they're wrong. Great for the child. The child is getting away with everything here, but how is that educational? It's not educational and reinforcing errors. So we've got to be really careful. And you've got to be really careful what you're not doing is saying, okay, I know the system isn't going to work very well for, let's say, that accent or that dialect or whatever. So what I'm going to do is just drop the bar for everyone because we just want to give kids confidence. We want to get them to pronounce stuff. Again, we got to be really careful of that. Is it really having a positive effect on education, or are, just to get AI and technology in front of kids, are we dropping the bar so low and letting kids pass stuff that really it's not actually having a net beneficial value on the children, on any of the children, because they're not getting the right positive closed loop feedback. And this is really important. What happens with voice technology is that the feedback loop is correct. So what do I mean by the feedback loop? I mean, there's multiple ways to look at this, that the child is reading, they're pronouncing something, they're recalling something, they're answering a question. Using voice technology can give the child immediate feedback, even when there isn't a helpful adult available to them. Whether that's in the home because they're remote learning, or if it's in the classroom because simply by the fact that this is a daily exercise and the teacher can't possibly have the time to sit with all kids, 25, 30 kids in the classroom every day, or maybe it's several times a week. Equally, the teacher's time is already stretched, but we all know the practice is very useful for them. So we want to be able to do, that's the immediate feedback to the child, but it's also feedback on the assessment to the teachers, the school, the district, etc. So that's the feedback loop. Is it coming back straight back to the child, or is it coming to the supervising adults? So that's accuracy. It's super important. Something SoapBox Labs takes really, really seriously and have delivered in a high accuracy systems beyond anything else in the market. That's really important. But what we also do is we work in real world noise conditions. And that was one of the things when we started the company we wanted to address. We didn't think there was any point developing a system that wasn't going to work in the real world. All our speech technology systems work in the real world. They work in our noisy kitchens and our environments and outside and insides and cars and stuff. It was super important to get that bit right because there was no point putting all this effort in if it was going to fall over every time there was a small bit of background noise. So when I mean background noise, like I said earlier, we're talking about adults talking, classrooms, kids, dogs, TVs, but also, is this going to work on a cheap iPad, cheap Android, maybe an expensive iPad? Will it work on systems that have high-end microphones, but also maybe cheap low-end microphones. Does it require an expensive headset? Because that's adding a huge complexity to a 4-year-old or a 6-year-old, constantly touching. There's an extra expense associated, more chance of them breaking. We know voice technology works for adults in the real world, but without headset mics. And for us, it was super important to be able to bring this technology to the market that works in those real world conditions as well. And that's what we've done. Accents and dialects. We get this question all the time, and it's a really, really good question. Does it work with accents? So what we have done is collected voice data from over 192 countries. That's children's voice data from 192 countries to ensure we were able to deliver accuracy for all accents. What we've also done is looked at dialects and how that's handled. If you think about it, in the US alone, there's 12 dialects in the US. It is really important. People often forget about the dialect issue as well, that we're not just dealing with accents. So English language learners, people with from all over the world. We're looking at also that cannot handle children from all backgrounds and all socioeconomic areas in the US and globally, and can we handle that in a way that those children aren't having a different experience to their classroom mates, right? So this is really, really important. How do you mitigate bias? Mitigating bias is a huge issue in AI in general. And it's been attention has been paid in the US, in the EU to this. When you start to bring out AI systems, how do we ensure that there isn't bias in these systems? So what SoapBox Labs have done, have worked and had independent validation that there was first of all, in terms of accuracy, there was a strong consistency between assessor rating and children verification rating on an item level accuracy in kindergarten blending and expressive vocabulary. That was hugely important to us to achieve that. But also extremely important, and there's no point building systems if you can't support this, is that there was no bias in scoring our speech verification between white and black students, white and Latina students, or students from high versus low poverty backgrounds. And that is a huge badge of honour for us to be able to say that we've developed a system that does not show bias between kids, and we continue to ensure that that never creeps into our system. So it's a huge importance. I just want to talk about the importance of evaluation. How do you know your system is performing well? How do you know if a system you're evaluating for use has bias? How accurate is it? You've got to be really careful. There's a couple of things evaluations can do is to mask. If you're just evaluating using very clean data, right? So the child has said it perfectly. They have, a dialect from, let's say, a majority of people in the US. There's no background noise. They've said they didn't stumble once. That's a very different evaluation data. If you're going to test it, a system. What happens? What's important to do and how we build our system is we check for the really clean data, of course, but we also check what happens when the child doesn't read it correctly. How does the system respond? Does it respond intelligently to a child mispronouncing something, not reading something, skipping a word, skipping a sentence? What happens? How does the system handle that? And that's super important when evaluating systems. The evaluation data sets must be diverse. They must be representative of all the kids that are going to use the system. And you've got to be really clear in your evaluation that when you do an evaluation over a whole cohort of children, that poor performance or bias for a small subset of children is not masked, because let's say on a whole, all the kids, it performed pretty well. But what happened was every time there was even a small error, it was always with the same cohort of kids. So what could happen is that some kids get 0 errors. It works perfectly for them in all scenarios. But a couple of kids are hit every time there's an error. It's always the same kids. Now, can you imagine being a child in the classroom? We talk about equality in education. Can you imagine a child in the classroom? It's working for all their peers. It's responding to all their peers. It's hearing their peers and not them. And when they use it, it tells them they're wrong. Or tell them they're right when they're wrong, or wrong when they're right, and they know it, and they know that system's not performing them. That's not helpful. It's not helpful for education. So we have to, as an industry, ensure we're not adding to the problem of inequality. We're trying to improve it. So kids' digital privacy, this is a serious hot button issue. The FTC is constantly reviewing, has been only recently reviews COPPA again. The EU with GDPR. This is something that all systems, particularly when it comes to our children's data, we need to be super aware of. SoapBox Labs has always taken a privacy by design approach. From our inception in 2013, we've worked with Prevo in the US to ensure that every step of the way in how we built our system, how we collected our data, how the data that was used was in full compliance with COPPA and EU GDPR when it came online in 2018. So we've always taken that seriously, primarily because we know as parents as well as technologists how important this is and how sensitive our own data is, but particularly our data with kids. And what we do again is to call on transparency in the industry. It's a simple thing to do. It's not just that we get permission from the parents and the guardians and the teachers in the schools and everybody required. That's really important, and that's compliance. But on top of that, to go that extra step further and to have transparency and to say, as SoapBox Labs, we never use the data for anything other than to improve the service. It is never used for marketing. It's never used for product placement. It's never going to be resold. And that has always been a very red line issue with us, because we knew that when we were bringing this product to market, we wanted to be able to stand over everything we've ever done. And trust is not just in trust that the system works. It's in trust that the system respects children's digital privacy rights. So we've set the benchmark for privacy, and we've been trusted by our partners around the globe, and we continue to build on this, and we continue to build on our partners, ones that we can share with you today and in the future and this year more and more again. So just want to walk you through the SoapBox Labs engine. So what we have is on the right hand side all how we support education for reading practice, assessment, screening, in form of fluency assessment, pronunciation assessment. Now, these right down to the phonetic level and how we respond. Multiple choice questions, reading practice, keyword spotting, so comprehension questions. So not just that the system listens as a child reads, but a question can be posed and the child can ask in a very natural way, and the system can find the answer within their response. Allowing a child to practice reading is super important. We know that frequent practice, how important it is, as well as more formative, but also summative assessments. And we support our partners in how they deliver their fluency, for example, in their own individual way. And that's a partnership we have carried out most recently with Amplify, but other partners as well. On the left-hand side, we have our wake word, our voice search, our speech-to-text transcriptions, voice activity detection, how we have conversation, and voice control. So any of these as well is used primarily in more learning and, to use the word edutainment, that some people don't particularly like, but it's actually quite descriptive of the fact that most learning engagements using voice with kids can be hugely educational as well. How we teach them, how we develop their vocabulary, how we create these imaginative dialogue, conversational experiences with virtual characters, with their favorite animation characters as well. All those experiences can be hugely educational for children as well. As I was saying, to some of the use cases there, and on the right we can see that we have help. Our system does support language learning, reading practice, speech therapy, social emotional learning, reading assessment, and dyslexia screening. On the other side, conversation, voice commands, voice search, control, accessibility, and voice assistance. So our underlying engine delivers API points that supports our clients. So again, we are focused on our voice technology, and we have support our clients in use cases on both sides of this equation here. So a child's reading journey, just to dive a little bit more into how the system supports, given this is the AAAI conference, is that for language development when a child is very, very young. So that can be in vocabulary and how babies and toddlers and very young kids start to pronounce sounds and then syllables and then phonological awareness, phonemic awareness, phonics, how the blending, decoding for words and then sentences, right up to how kids do fluency and fluency assessments as well as English language learning. To just give you a little taste of how that works. And what we know is that if you support our clients, and how we support our clients is in order to start early, screen, practice, assess and intervene when necessary. So our voice technology allows our clients to be able to deliver these types of supports to students that we know help advance their reading journey. To recap on that, our system enables practice and immediate feedback to the kids. It can deliver progress data to parents and teachers. It can perform formative and summative assessments. And it can assess phonics, words down to the phonemic level as well, sentences, as well as for reading fluency. And that includes deletions, substitutions and assertions. So I'm just going to play a quick video here that just summarises a couple of the use cases.
Can you tell Hush what this is? Can you say, this is a pencil?
This is a pencil. 你看我好高，哎。
Nice job. Try that once again.
It is lots of dogs.
Try again.
It is lots of fun.
Yay! Old woman and a little old man.
So just to summarise, and thank you for listening today, but what we really feel is important is that it's extremely hard to imagine a future where voice is not a key feature in all kids' learning tools, games, devices and experiences. And I'm sure you would agree with that too. So thank you for listening.